So you can see the s orbital here. So this is the s orbital, so you can see that, and we have the p orbital here. So this is the p orbital, so you can check, you see, so you can check everything very clearly. So this is, this is the s orbital, so, and this is the p orbital. You can see it very clearly. So you can see this s orbital and the p orbital, they are merging together, and you can see they are forming this sp3 hybrid. See, so let's understand the hybridization using a simple example. Okay, so we have carbon atom. So you know very well that the carbon atom could form, 4 bonds. Okay, it could form 4 bonds with 4 different atoms. Okay, so here let's see how this carbon atom, could form, all these 4 bonds. Okay, and how could this carbon atom form single bond, double bond, and the triple bond. Okay, so actually the carbon is making these bonds based on the hybridization. Okay, so let's talk about it. So first of all, let's talk about one type of hybridization, that is called sp hybridization. Okay, so sp hybridization, we call it as sp hybridization. Okay, so in that sp hybridization we have one s orbital and one p orbital. That's why we call it as sp hybridization. So we have here, we have one s orbital and one p orbital. So you know the shape, right? So this is the shape of, s orbital, and this is the shape of p orbital. So we have one s orbital and we have one, p orbital, so that equals this one. So this is that, sp orbital. So this is the sp orbital. So this is the shape of the sp orbital. Okay, now let's talk about the sp2 orbital. So now let's talk about the sp2 orbital. So in order to create sp2 orbital, we need, you see, from the name itself you can understand, understand the requirements in to create sp2 orbitals. In order to create sp2 hybridization, you need one s orbital, that is here one s orbital, and you need 2p orbital. You see, 2p orbital. So you need 2p orbital. You see, you have 2p. This p orbital in x axis, and this p orbital is in y axis. Okay, so actually you need 2p orbital and one s orbital to create sp2 hybrid orbital. So so this is the shape of that, sp2 hybridization, so hybrid orbital. Okay, so in order to create sp3 orbital, now you can tell from this, okay, from this name itself you could, come up with the answer. In order to create sp3 orbital, you need one s orbital and you need 3p orbitals. Okay, you see here, you need one s orbital and you need 3p orbital. It's here, you need 3p orbitals. Okay, so that's how you create sp3 hybrid orbitals. Okay, so this is the shape of, this is the shape of that, sp3 hybrid orbitals. Very simple. Okay, so let's talk about how, carbon atom, okay, how carbon atom, creates its hybridization. Okay, let's talk about the mechanism. So you can see that this is the structure of carbon atom. So carbon has this first energy level. So this is the first energy level, and this is the second energy level. Okay, so in the first energy level, it has one orbital. Okay, so that is s orbital. Okay, in that s orbital you have two electrons. Okay, and the carbon has the second energy level. In that second energy level, it has one s orbital and one p orbital. It has one s orbital and p orbital in its the second energy level. That's why we say it is 2s and 2p. So 2s doesn't mean we have 2s orbital. It means actually this s orbital belongs to this second energy level. So that's why we use second here. And for 2p, it doesn't mean that we have two p orbitals. It means actually p orbital here belongs to the second energy level. So that's why we are putting 2 and 2 here. Okay, it doesn't mean the number of orbital. It means which energy level this orbital belongs to. So in that one s orbital, okay, actually this second energy level has one s orbital and one p orbital, right? So one s orbital contains two electrons. Okay, s orbital looks like this. Okay, p orbital actually look like this. Okay, so in s orbital you could accommodate two electrons. You cannot accommodate more than two electrons in s orbital, but in p orbital you could accommodate up to six electrons. You could accommodate 1 2 3 4 5 6. You could accommodate 6 electrons. Okay, but we have for carbon atom 4 electrons in its second energy level, and the two of them goes to the s orbital. So we are remaining with other two electrons, so that would go to this p orbital. Okay, so p orbital will be like this. So one orbital will be empty, one shell, not orbital, one shell will be empty, and it'll accommodate each one electron in its shell. Right, so here you can see the energy level diagram. So here this is the first energy level. Okay, that that first energy level has one s orbital. Okay, that has two electrons. Okay, so this orbital is not available for bonding. You can see it's not available for bonding because it is very stable. And it is very closer to nucleus, so the nucleus would keep it under control. So it won't be available for bonding. Okay, but these are the valence energy level. Okay, so in that valence energy level we have valence orbital. Okay, these are the valence orbital, and we have valence electron. Okay, the electrons resides in this valence orbitals are called valence electrons. So these electrons are available for bonding. Okay, so carbon has carbon could pair with carbon could bond with 4 atoms, right? So this is carbon atom. It can bond with 4 atoms. Okay, so but in this case you see this orbital, how basically, right? So in order to bond two orbitals of different atoms should overlap each other. That's how the bond forms. Let's say So this is one orbital of X atom. This is another orbital for Y atom, of the Y atom. So these two overlaps, that's how the bond forms. Okay, so in order to form a bond you need orbitals, and that orbital should should not be filled fully. So based on our information, this cannot be used for bonding purposes, that we already discussed, and these two can be used for bonding purposes, okay. But actually this orbital is filled, it's completely filled, you see. So this orbital doesn't like to form a bond with another molecules or another atom's orbital, because it's totally filled here, okay. So we can use only this p orbital for bonding purposes. So usually we know that carbon could make 4 bonds, okay. So with this concept, you can see it can make only one bond, because to create a bond you need one orbital, whether it's s, p or d, okay. But you need an orbital. That orbital should be filled halfly, or at least it should be with 0 electrons inside. But in our case here it's fully filled, and here we have one eligible candidate to form a bond, okay. So that's a confusion. How come a carbon forms the remaining 3 bonds? Because carbon forms 4 bonds, right? So how come the carbon forms the remaining 3 bonds? That means how come a carbon forms 4 bonds? So in order to make bonds, carbon goes into this hybridization status. So in that hybridization status, in that process, it creates 4 orbitals. So with 4 orbitals it could create 4 bonds. So with 4 orbital it could create 4 bonds, okay. So how it happens? There are some ways to create 4 bonds, okay. So this s orbital could hybridize with this 1p orbital, and it could form sp orbital. That is one thing. Or this s orbital could hybridize with this with this 2p orbital and could create sp2 orbitals. Or else this s orbital could hybridize with these 3p orbitals and could create sp3 orbital. So there are 3 ways a carbon atom could form 4 bonds. Let me explain about it. So let's talk about the sp first. sp hybridization. So in this sp hybridization, what happened here is one s orbital and one p orbital combine together and they create this sp hybridization, okay. In this sp hybridization, it creates 2 orbitals. It creates 2 orbitals because s is 1 orbital and p is 1 orbital, and it combines together and they create 2 orbitals. So let me put in this way. So this is s orbital, and this is p orbital. They combine together and they form something like this. They form something like this, 2 orbitals, okay. So basically they form 2 orbitals. and the energy level of those two orbitals would be somewhere here, somewhere here. So somewhere here, because this is the energy level of p orbital, and this is the energy level of s orbital. So when we combine both these two orbitals, the energy level of this newly created hybrid orbital will be here, somewhere here, right in the middle, right? Because we have s orbital and we have p orbital. So s is 50% here, and we have p that is 50% here. So 50-50. So the energy level of this newly created hybridized orbital will be somewhere here in the middle. Okay, so in the middle, it's not here or not here, it's somewhere in this line. Okay, so this s orbital is used to create this hybrid orbital. So it is no more, this orbital is no more. Okay, this is destroyed, not destroyed actually, this is no more because it's used to create this hybridization. Okay, so this is used, and this one p orbital, that is also used to create this hybridization. So it's also gone. Now we are left with two hybrid orbitals, sp and sp. These are two hybrid orbitals, and we are left with two p orbitals. You see, two p orbitals. Okay, these p orbitals are unhybridized. These are unhybridized. Now with this two p orbitals, we could form two bonds with other atoms. Okay, and with these two unhybridized p orbital, we can form two bonds. Alright, we can form two bonds. So 2 we can make 4 bonds. Now you see, these two bonds are different. You can easily understand that, because it is made from these hybridized orbitals, and these two bonds are different because that is made from these unhybridized p orbitals. Their characteristics should differ. Okay, so these two bonds, okay, which is made from this sp hybridized orbitals, are always sigma bonds. So in other words, when you create a bond by two hybridized orbitals, then that bond becomes a sigma bond. So in order to create sigma bond, you need hybridized orbitals. Okay, simple. Okay, and these bonds will be pi bonds. Okay, now you can understand. Okay, so pi bonds are only created when you use unhybridized orbitals only. Otherwise you cannot create any any pi bonds. So based on this information, so this carbon has 2 sigma bonds and 2 pi bonds. So altogether it has 4 bonds. So how can we write this? So here the carbon is here. So this carbon has 2 sigma bonds and 2 pi bonds. Let's make total bonds here. So it is 4 bonds. Okay, fine. But two of them are sigma bonds, and 2 of them are pi bonds. So you have to understand that so here only sigma bonds could make single bond. No other bonds could make single bond. Only sigma bond can. Okay, pi bonds could make only the double and the triple bonds. So when you see a single bond, there is always sigma bond. So when you see a double bond, one of the bond in that double bond is sigma bond and the other bond is pi bond. Okay, and when you see a triple bond in a compound or in a molecule, and one of the bond is sigma bond and other twos are the rest of the bond, other twos are pi bonds. Okay, so you have two pi bond and one sigma bond in triple bond, and you have one sigma bond and one pi bond in a double bond. Okay, so based on this, in this carbon atom we have two sigma bonds and we have two pi bonds. So sigma bonds only create single bond. So we have one sigma and we have one sigma, and we have two pi bonds. You know that very clearly. Pi bond cannot create single bond, but we have two single bond here. So this is wrong. This is totally wrong. So pi bond only makes what? Double or triple bonds. It cannot make a single bond. So this carbon should be like this, because pi bond only creates double bond, it cannot create single bond. So this carbon should be like this. This carbon should have two double bonds. This is how you relate hybridization and sigma and pi bonds and the single, double, triple bonds. So let's talk about the sp2 hybridization. So in sp2 hybridization, we need one s orbital and we need two p orbitals, right? Two p orbitals. That's why we put 2 here. We need two p orbitals. Okay, so this orbital and these two orbitals, they all combine together and they form sp2 orbitals. So they form actually three sp2 orbitals. They form three orbitals. They form actually three hybrid orbitals. Those are sp2 hybridized orbitals. Okay, so each sp2 orbital comprise one s orbital and two p orbitals. That means this is 33.33% and this is 66.66%. Okay, so the energy level would be close to p orbital, because p is the majority in this. P is the majority here in this hybridized orbital. So the energy level somewhere like this. Okay, the sp orbital's energy level is in the middle. It's exactly in the middle, but the sp2 hybridization's energy level is somewhere above this sp2 orbital, somewhere here. So this create three orbitals. So actually you should consider these as orbitals. These are not shells. Okay, because this box and this box are similar, but this is actually shells. Okay, so I'm talking about the orbital. So I'm changing the shape of it. Let's say, okay, I'll put triangle. Okay, so I'll write triangle. So these are the orbitals. So it creates three different orbitals. So this s orbital is actually used to create this hybridization. So it is over. It's finished. Okay, and these two p orbital are used. So no more. So now we have three hybridized orbitals. Those are sp2 hybridized, three sp2 hybridized orbital, and we have one unhybridized p orbital. Okay, now check. Okay, orbital. So hybridized orbital form what? sigma bond. So we have how many sigma bond? We have 3 sigma bond, because each orbital contribute 1 bonds. Okay, 1 bond. So we have 3 sigma bond. And we have how many unhybridized orbital here? We have 1 unhybridized orbital here. That is what? That is this unhybridized pi bond. So usually unhybridized orbital creates what bond? That is pi bond. And how many unhybridized orbital we have? We have 1 unhybridized orbital. So this carbon could create 3 sigma bond and 1 pi bond. So altogether it creates 4 bonds. So normally pi bond, it only contribute itself into double bond or single bond, double bond or triple bond, not the single bond. But sigma bond always contribute in single bond, double bond and triple bond. But when you have single bond only in an atom, that is actually sigma bond. So you know that. So basically this is the carbon. So let's put the default default bond for carbon. It has 4 bond, but we have 3 sigma bond. So 1, 2, 3, that's fine. Sigma is anyway single bond. It could form double bond and triple bond as well, but basically that is single bond. So, and we have 1 pi bond. Okay, but pi bond only comes in the double or triple bond, not the single bond. So these are, let's say these are sigma bonds, and we can't say this is the pi bond, because pi bond can't make single bond. So this is wrong. So we have to put this pi bond into somewhere here, somewhere to one of these sigma bonds. Let's put it here. So this is how this carbon looks like. So this carbon has 1 double bond and 2 single bonds. Simple. So now let's talk about the sp3 hybridization. Now you know that in order to create sp3 hybridization, you need 1 s orbital, that is here, and you need 3 p orbital. These 1, 2, 3. These 3 p orbitals. Okay, so we are going to use everything here. Okay, so these all 4 orbitals, 1, 2, 3, 4 orbitals combines together, and they form 4 orbitals, 4 hybrid orbitals. Actually these 4 orbitals are hybrid orbitals. They are sp3 hybridized orbitals. So they will create 4 sp3 hybridized orbital. Okay, so basically in this orbital, in this one hybridized orbital, we have 1 s orbital and we have 3 p orbital. So the percentage of the s orbital here is, so the percentage is, this is roughly 25%, and this is 75%, because we have 3 p orbital here, but we have 1 s orbital here. So this is actually over 1 over 4, and this is actually 3 over 4. So that is 1 over 4 means that is 25%, and 3 over 4 means that is 75%. So let's compare the energy level with sp orbital and sp2 orbital. So here p is the majority, that is 75%, and in sp2 orbital the majority p has 66%. In sp orbital, the p orbital has 50%, but here it has 75%. So this energy level is higher compared to these sp2 and sp orbitals. So this must be somewhere here. So this is this is the energy level of the sp3 orbital, and this is the energy level of sp2 orbital, and this is the energy level of sp orbital, somewhere here. Okay, so let's talk about, alright, so we have 4 hybridized orbital here. So we have 4 hybridized orbital here. So this one is actually used, Okay, this is also used because in order to create hybridization, sp3 hybridization, we need one s orbital, so that is used, and we need 3 p orbitals, so we used all these 3 orbitals. Now we are left with what we have: 4 hybridized orbital, and all these 4 orbitals are what? Hybridized. Hybridized mean this hybridized orbital only creates what bond? Sigma bonds. And we have 4 orbitals, that means we have 4 sigma bonds. Sigma bonds. So this hybridization would be like this, because we have 4 sigma bonds. We don't have any pi bonds to create double bond or triple bond. So all the bonds of this carbon atom will be single bond. Simple. So this is the hybridization. So this is the connection or the relationship between hybridization and the sigma or pi bonds and the single, double, triple bonds.